question number 7. That's what we're doing right now. Question number 7 is a pop fly problem. So right away, let me draw a beautiful picture. We have something going up and coming back down. There's my pop fly, okay? And anytime we deal with a pop fly, I want you to understand that we always split that trip in half. Always, okay? You can look at the trip going up if you'd like. You can look at the trip going down if you'd like. All right. It changes a couple things, but you'd still get the same answer. So whatever you want to do, but you always want to split the trip in half because the key is that you know that the velocity at the peak, here, I'm going to do a nice rainbow color there. The velocity of the peak will always be 0. And now if you look at the trip going up, that velocity will be, if we're talking about it going up here, then the velocity will be a final velocity. If we talk about the trip going down, that'll be an initial velocity. Just depends on which way you want to attack the problem. Okay, now, because we split the trip in half, we will always need to split the time in half too. And I'm going to tell you that most students with this problem, the first time they do it, they make the mistake of forgetting to split the time in half here, okay? So what happens too is that their answer ends up being 4 times the actual answer. So I'm going to warn you now, you always have to split the trip in half, including the time first. All right, so let's look at the time. This is the total time in the air, which is 5.17 seconds. So I'm going to do that time total is equal to 5.17. And I'm going to divide that by 2 right away. And so we have 5.17 divided by 2 equals 2.585. Boom. All right, and that is the time I need to use in this calculation because it's going to be half the trip. All right, now, what else do we need to look at? So let's list our givens now. So time is going to be 2.585. All right. I'm going to look at that. We're talking about something falling down. I think it's easier, or we're looking at distance. I think it's easier to look at the trip falling down. So I'm going to say my initial velocity, which is what's at the top, at the peak, is 0. Okay. And I'm going to say, what else? I am given acceleration, always, negative 9.8. Okay. And what else do I need? I need how far, xf/d equals question mark. Okay, so there we go. Now, let's look at some of the other things then, or let's think about the equation. So I have time, I have velocity, acceleration, and I have how far. So if you're not sure, you can ask yourself 2 questions to cancel out the equations, but I see the big ugly here. So I'm going to pick the big ugly equation. xf is equal to xi plus vit plus 1/2 at squared. All right, start crossing stuff out. xi, if I don't ask for or give it, my initial position is 0. Okay, my initial velocity is 0. That's why I kind of picked the trip falling down, is that I can make this initial velocity 0. Okay, so all I have left is 1/2 at squared. I'm going to plug that in. So 1/2 times negative 9.8 times 2.585 squared. And I'm going to multiply it out in my calculator. So again, 0.5 for the 1/2 times negative 9.8 times 2.585 squared. And I get for my answer to be negative 32.74. Now, it doesn't ask about a position. It doesn't ask about, how far down does it fall. It's really saying how high up does it get. So in this problem, you will actually have a positive answer. So you can not worry about the negative. It's just going to be a positive 32.74 for mine. Obviously, your numbers are different, but you'll have a positive answer for that problem. All right. Thanks so much for watching.